Good morning, Msce candidates. The heat is on. Exams are around the corner. From Black Slides, we wish you all the best. Okay? So don't panic. Just be yourself. Remain calm. You have already fought a good fight. You have studied for 2 years. Now it is time to reap what you have sown. So welcome, just a quick revision of some topics. The emphasis is on how to maximize marks when answering questions. So welcome to this topic, just a quick revision in form of questions. Uniform circular motion, which is motion of a body in a circular path. So without much ado, the first question is saying define angular displacement. Remember, definition is always 1 mark. So angular displacement is defined as the angle subtended by an arc at the center of a circular path. That's angular displacement. Okay, so as a body is moving in a circle, in a circular motion, in a circular path, let's suppose we have a body which is moving in a circle, right? Suppose we have a body moving in a circular path. Let's say this body here. Let's say we have a body. So suppose this is a body, an object moving in a circular path. As it moves, as the object moves, suppose it moves in this way, right? It is also covering an angle at the center of the path. So this angle here, denoted by theta, is called the angular displacement. So it is the angle subtended by an arc at the center of a circular path. So at some moment, the object will be here. The object will be seen somewhere here. Okay, so this angle here is called the angular displacement. In some cases, we define angular displacement as the angle swept by a moving object at the center of its circular path. Okay? So definitions don't attract as much marks as one may think. It's just 2 marks, 1 mark. Number 2, define a radian or define a radian measure. We define a radian measure as the angle subtended at the center of a circle by an arc of length equal to the radius of the circle. All right? So let's suppose the body is moving in a circular path, such as this. All right, so suppose at some moment, motion starts from some point here. Okay, and it covers a motion such as this. So as it is doing that, it is also covering an angle at the center. So if the length of the arc is this length, if this length has the same length as the radius, let's say this is 1 meter, the radius is 1 meter. Suppose, let's just redraw this. Suppose we have a circular path. Okay, so suppose the body starts moving from some point there. Okay, in a circular path. So let's say it has covered this arc length. Okay, so when the length, this is the center, when the length of the circle, let's say this is 1 meter, is equal to the length of the radius, then this angle here is called a radian. A radian. So a radian is just an angle subtended by the arc. So the arc in question is this one here. So when the arc has the length equal to the length of the radius, then this angle is called a radian. Okay, take note of that. All right, the next question, number 3, define centripetal force. Definition of centripetal force. We define centripetal force. Centripetal force is just the force that is required to keep a body moving in a circular path, and it is directed towards the center of the circular path. Okay, so let's say we have a body moving in a circular path. Suppose we have a body that is moving in a circular path. Okay, let's say the body is somewhere here and is moving in a circular path. Okay, this path here. Okay, right, so there's a force which is pushing or pulling the body towards the center. This force is called the centripetal force. So center seeking force. Centripetal means center seeking force. So we define centripetal force as simply the force that is required to keep a body moving in a circular path and is directed towards the center of the circular path. All right. Define, number 4, define angular velocity and state its SI unit. Angular velocity is the rate of change. Definition: angular velocity is the rate of change of angular displacement. Its SI unit is radian per second. Okay, so we are saying angular velocity, which is represented by this symbol omega, is simply the angle swept in radians multiplied by time t. So since the angle is in radians and time is in seconds, then the unit of angular velocity is simply radians per second, in short written as rad per second, rad per second, rad per second. Okay, it is going to be important. It's important that you understand the definitions and their SI unit, definitions of quantities related to circular motion and their SI units. Number 5, distinguish between linear velocity and angular velocity. This is a very common question in the Msce. All right, so you can distinguish the two using their definitions. Okay. Linear velocity, it is the measure of rate of change of displacement. It is just a displacement with respect to time when an object moves along a straight line. This refers to an object that is moving in a straight line. So the rate of change of displacement, the Q word there, take note, displacement with respect to time, or simply displacement per unit time. Displacement per unit time. This is written as displacement divided by time. So since displacement is in meters and time is in seconds, then the displacement is measured in meters per second. Right, so it is a measure of the rate of change of displacement with respect to time. Or if you want, you can simply say the linear velocity is displacement per unit time. Displacement displacement covered per unit time. On the other hand, angular velocity is the rate of change of angular displacement. Take note, this one is the rate of change of displacement, or if you like, just to show that these are different, you can add the word linear displacement. Okay, so linear velocity is linear displacement divided by time, or the rate of change of linear displacement per unit time, whereas angular velocity is the rate of change of angular displacement. All right, another difference can be seen in the units in way of measure. The SI unit is meter per second. Take note the spelling for meter. It's metra. It's metra, like that. Metra. M-E-T-R-E. Meter per second. The unit of angular velocity is radian per second. So we are saying you can give differences in terms of their units or using their definitions. Right. Number 6, state what is meant by centripetal acceleration. Centripetal acceleration is simply defined as the acceleration of a body towards the center of a circle. Simple. Remember that centripetal means center seeking, or moving towards the center. So centripetal acceleration is the acceleration of a body towards the center of the circle, or a body that is moving in a circular path. All right, then define critical speed. We define critical speed as the minimum speed that an object moving in a circular path must maintain in order to avoid skidding off the track or moving out of the track. It's called critical speed. Explain why bodies in a circular motion undergo acceleration even when their speed is constant. So a body moving in a circular path undergoes acceleration even when their speed is constant, all right? The body moving in a circular path is said to accelerate even if its speed is constant, because its velocity keeps on changing with time. As the direction also changes, the rate of change of velocity also occurs, thus resulting in acceleration. Remember that acceleration can be in two ways. It can be the change in its speed as well as the change in acceleration. In velocity, direction of velocity. All right. So since the velocity is not in one direction, it keeps changing in a circular path. Therefore, the body is said to be accelerating. Explain why the moon is said to be accelerating when revolving around the Earth at constant speed. The same reason. It's simply because there is a change in velocity because of its change in direction. So we are saying the moon is said to be accelerating when revolving around the Earth at a constant velocity because its velocity keeps on changing as the direction changes with time. So the rate of change of velocity results in the moon's acceleration. Right. Then state number 10, question number 10, state two ways in which the centripetal force on the ball in its circular motion would be reduced. 1, by increasing the radius of the path. 2, by reducing the angular velocity of the ball. These are two ways by which centripetal force on the ball in its circular path can be reduced. All right, so I would love to stop on number 10. Number 10 is number 11. Number 11 is saying what is meant by the term banking in roads. It is the act of making the road such that the outer path is slightly raised above the inner side so that the track is sloping towards the center of the curve. This is what is meant by banking. I would like to stop now. Please go through the questions a number of times so that you master in case one of them is asked, you should know how to correctly answer it. My name is Mr. Pochloa, wishing you all the best as you continue to prepare for Physics Paper 1, which is coming not in many days from now. Thank you very much. Bye-bye.